What we're going to do today is multiplying radicals. Go ahead and put this in your ISN, your table of contents. Today's date is September 8th. Pause the video so you can go ahead and get this in your table of contents. September 8th, multiplying radicals, page 11. Then we're going to review. Okay, go ahead and start your video back up. Now we're going to review with simplifying large radicals. And what we learned about large radicals is that sometimes it's really hard to tell if it's a perfect square or not. And it's hard to find the largest perfect square because it's such a large number. So we're going to start with prime factorization and see if we can find a perfect square. So we start with 2 because 2 is the smallest prime number. And so what I'm going to do is start with 2. And I know 2 will go into 1,040, 520 times. Now, because I know that 520 is a prime number, I know, no, excuse me, not a prime number, but an even number, I can also divide that by 2. So I'm going to divide that by 2, and that goes into it 260 times. Once again, it's divisible by 2. So I'm going to divide it by 2. 2 goes into 260, 130. It ends in a 0, so I know it's divisible by 2. I keep going, keep dividing by 2 until I can't divide by 2 anymore, and I find the next prime number. So 130 divided by 2 is 65. Now, because it's not an even number, I know it's not divisible by 2 anymore. I can check to see, but I know that it's not divisible by 3 because of the divisibility rules. But since it ends in a 5, I know it's divisible by 5. So I divide 65 by 5, and I get a 13, which is a prime number, so I can stop there. Now, the next step was to circle all of the pairs of prime numbers. So if I circle the pairs of prime numbers, I'm going to circle those two. So we rewrite the radical as 4. That came from this, 2 times 2, times 4. This came from 2 times 2, times 5 times 13. Now, if I want to rewrite that, I can. I can do 4, square root of 4 times square root of 4 times the square root of 5 times the square root of 13. Square root of 4 is 2. Square root of 4 is 2. 5 and 13 are not perfect squares. I can't get the square root of them. So I'm going to just leave 5 times 13. 2 times 2 is 4. And inside the radical, I can't do anything with those two numbers. So I'm just going to multiply them back together and get a 65. Okay, so that's just a review. You should be writing this on your paper. Okay, now let's do a review of adding radicals. So when we talked about adding radicals the other day, we understood that if the number, the radicand, the number that's underneath the radical is the same number, then we can add those two together by their coefficients. But notice these two numbers are not the same. The radicands are not the same. So we can't add them together. So we just bring the answer down like it is. There's nothing we can do with that number. It's simplified. Let's look at the next one. The next one, the radicands are 6. Both of them have the same radicand. So we're going to be able to add these together. But what we add together are the coefficients. And the coefficients are the 8 and the 5. So that's going to be 8 minus 5 times the square root of 6. We keep whatever is in the radicand. So 8 minus 5 is 3. times the square root of 6. Let's try another one. Okay, now in this example, we see that the radicands are not the same, but I can tell by looking at the second radicand, the 12, that it has a perfect square factor, which means it's going to be able to be simplified. So I'm going to simplify that. So I'm going to bring down the 5 times the square root of 3 because I'm not ready to use that yet. And then I want to bring down the 3, and I'm going to simplify the 12. The 12 has a perfect square factor of 4 because I know that 4 times 3 equals 12. So when I simplify this, remember, I'm going to take out that perfect square. So let me go ahead and bring down 5 times the square root of 3 plus, now if I get the square root of 4, that's going to be 2. So I'm going to take that out and I'm going to multiply the 3 times the 2. What does that leave in the radical? That leaves the 3 over here because that did not have a perfect square factor. So now let's simplify even further. 5 times the square root of 3 plus 3 times 2 is 6 times the square root of 3. So what we did is we simplified this part of the expression. Now I can see that they do have the same radicand, so I can add them together. So I add the coefficients together. 5 plus 6 is 11 times the square root of 3. Try one more. And you know, on this next one, if you want to pause the video and try it on your own and then check it, I think that would be a good opportunity for review. So looking at this one, it has 2 different radicands, but what I know about 8 is that it has a perfect square factor. So I'm going to simplify 8. 8 has a perfect square factor of 4 times 2 plus 3 times the square root of 2. The 4 is a perfect square, so I'm going to take it out. So the square root of 4 is 2. That leaves a 2 inside the radical because it's not a perfect square, plus 3 times the square root of 2. Now, because they have the same radicand, the 2, I can add the coefficients together. 2 plus 3 is 5, and the 2, the radicand, stays inside the square root symbol. Okay, so that's just a review of adding radicals. Please go back and look at my videos in Schoology if you have any more questions about how to do some of these radicals. So now let's move on to multiplying. Multiplying is not that hard. You just have to remember to multiply, and you have to remember what to multiply. So you need to write this in your notes. So when you're multiplying, you multiply the coefficients together, and then you multiply the radicands together. Okay, that's what you need to know. Once again, multiply the coefficients together, and then multiply the radicands together. So I'm going to start with the coefficients. The coefficients are 4 times 3, so I'm going to multiply that, and that's 12. Then I'm going to multiply the radicands together. 3 times 2 is 6. I've done the multiplying. Now the last thing I want to do is I just want to make sure that it can't be simplified, because if it can be simplified, you need to do that. So when I look at 6, I know that 6 only has 2 factors, size 1 and 6, but 2 and 3. And none of those factors are perfect squares. If I can't have a factor, if I don't see a factor that's a perfect square factor, then it's simplified. So that's the answer to example 5. Let's try another one. Okay. Once again, I'm going to multiply the coefficients together. That's the steps. Write it down. Multiply the coefficients together. So the coefficients are 3 times 4. 3 times 4 is 12. And then I'm going to multiply the radicands together. 2 times 12 is 24. Next step is to check to see if it can be simplified. So when I look at it, I know that there's a perfect square factor of 24. And I know it's 4. Because if you think of the factors of 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. The only perfect square factor of all those factors is 4. So we're going to rewrite it so that we show those factors. Now that we know that we have a perfect square factor, we know that we take that perfect square factor out. So the square root of 4 is 2. So we're going to bring down the 12 times the 2. And that leaves a 6 inside the radical. That's supposed to be a multiplication sign. It's not really doing what I want it to do, but that's multiplication. Okay, so now we're going to multiply the coefficients together. 12 times 2 is 24. And the radical of 6, the radicand of 6, it remains there. It does not have a perfect square factor. Okay, we're going to try this one last example, example 6. Now, if you remember distributive property says you take what's on the outside of the parentheses and multiply it times what's inside the parentheses. So that means we're going to multiply these two terms together, and then we're going to multiply these two terms together. So we're going to start here. And the first coefficient is 4 times 5. So 4 times 5 is 20. And the radicand is 3 times 2, which is 6. Now I'm going to multiply 4 times the square root of 3 times 6 times the square root of 3. So I'm going to multiply the coefficient. 4 times 6, I'll bring the plus sign down. 4 times 6 is 24. And the radicand, 3 times 3, is 9. Next step is to see if we can simplify anything. So I look at the first radicand and it's a 6. And I know that the only factors of 6 are 1 and 6 and 2 and 3. None of those are perfect squares, so I just have to leave that as it is. The next one is a 9. And 9 is a perfect square. 9 is a perfect square in itself, so it can be simplified. So that would be 24 times the square root of 9, which is 3. So it totally comes outside of the radical sign because I could get the perfect square of it. There's no other number. So last step is to bring this down, 20 times the square root of 6, and then I can go ahead and multiply 24 times 3, which is 72. There's nothing else to do in this problem because I can't add anything else because there are no other radicals. All right. Hope you got all this in your notes. I will be checking for it on Notebook Check. All right. Thanks.